Our cosmic neighborhood just got a lot more interesting. Imagine you're looking up at the night sky, a familiar blanket of stars. Now imagine that one of those faint specks of light is not a star at all. It's an object, a visitor, something that has traveled for millions, maybe even billions of years through the cold, dark void between the stars. And you know, it's headed our way. This isn't science fiction. This is the reality we faced when astronomers first spotted 3I/Atlas. The initial alerts from observatories around the world sent a jolt through the scientific community. We had found another traveler from interstellar space, the third of its kind. But this one was different. This one was big. The discovery immediately sparked a global conversation, a mix of pure scientific excitement and, well, a touch of primal fear. Why fear? Because the unknown is always a little scary. When an object from another star system enters our own, we have no idea what it is, what it's made of, or what it's doing here. Is it just a lonely, wandering rock, a cosmic tourist passing through, or is it something more? The questions started flying faster than the object itself. Every telescope that could be pointed at it was, all trying to get a better look at this mysterious guest. The thrill of discovery is what drives science, but the shadow of the unknown always looms large in our collective imagination. This visitor, officially designated 3I/Atlas, didn't just knock on our solar system's door, it practically kicked it down. The sheer scale of the object, hinted at in the very first observations, was mind-boggling. The initial excitement quickly turned into a frantic race against time. This object wasn't sticking around. It was on a trajectory that would whip it around the sun and fling it back out into the interstellar abyss, perhaps never to be seen again. We had a limited window to study it, to unlock its secrets. Every hour of observation was precious. The pressure was immense, a cosmic deadline set by the laws of physics. We had to learn everything we could before our guest decided to leave. So what happens when humanity is faced with such a profound mystery? We do what we do best. We observe, we question, and we argue. The initial data was fuzzy, incomplete, but it was enough to ignite a firestorm of debate. Headlines around the world screamed with possibilities, from a simple giant comet to the more sensational idea of an alien megastructure. This is the beauty and the chaos of a major discovery. It pulls in everyone, from the most seasoned astrophysicists to the everyday person looking up at the sky and wondering, are we alone? 3I/Atlas didn't just give us data points. It gave us a mirror to reflect our own hopes, fears, and our unyielding curiosity about the universe. Let's talk about size. Because when it comes to 3I/Atlas, size is everything. It's the first thing that sets it apart and makes it so utterly astonishing. When we say this object is big, we're not talking about a big rock. We are talking about something on a geological scale. The best estimates, calculated from how it reflects sunlight, put its diameter at over 10 kilometers. That's more than 6 miles wide. To put that into perspective, think about the tallest mountain on Earth, Mount Everest. It stands about 8.8 kilometers tall. Now imagine a rock, a single solid object, taller and wider than Mount Everest, tumbling through space. That is the scale of our interstellar visitor. This isn't just a big comet, it's a veritable monster. An object of this size is a rarity even within our own solar system, let alone as a visitor from another one. Finding something like this implies that objects of this magnitude might be common out there in the galaxy, which, changes our understanding of how planetary systems form and what they eject into space. It's one thing to imagine small, planet-forming leftovers being thrown out into the void. It's another thing entirely to picture a mountain-sized behemoth getting the boot from its home star. This discovery challenges our models and forces us to think bigger, literally. The universe, it seems, operates on a scale that continues to humble us. How do we know it's this big? It's not like we can just take out a cosmic measuring tape. Scientists use a clever method based on light. They measure the object's brightness. But brightness can be deceiving. A small, shiny object can look just as bright as a large, dark one. The key is to figure out its albedo, how much light it reflects. By analyzing the light over different wavelengths and comparing it to known objects, astronomers can make a very educated guess. For 3I/Atlas, the data pointed to a very dark surface, one that absorbs most of the sunlight that hits it. To be as bright as it appeared while being so dark, it had to be absolutely enormous. The implications are, honestly, staggering. An object this large has a lot of gravity. It's not just a passive piece of debris. It's a significant celestial body in its own right. As it travels, it carries with it the chemical and physical history of its home star system. It's a time capsule, a message in a bottle thrown into the cosmic ocean, and it just washed up on our shore. To catch a faint, fast-moving ghost from another star system, you need a very special eye. In this case, that eye is the Vera C. Rubin Observatory. Perched high in the Andes Mountains of Chile, this observatory is a modern marvel of astronomy. It's not like a traditional telescope that points at one thing for a long time. The Rubin Observatory is a survey telescope. Its mission is to scan the entire visible night sky every few days. It's designed to detect change. Anything that moves, flashes, or varies in brightness gets flagged by its powerful computers. It's the ultimate celestial neighborhood watch, and it was tailor-made for discovery like 3i/Atlas. The observatory's massive 8.4-meter mirror collects an incredible amount of light, allowing it to see objects that are millions of times fainter than what the human eye can perceive. Its camera is the largest ever built for astronomy, capturing vast swaths of the sky in exquisite detail. When 3i/Atlas entered our solar system, it was just a faint, barely moving dot against a backdrop of distant stars. For most telescopes, it would have been just another noise in the data. But Rubin's sophisticated software is designed to connect the dots. It saw a faint point of light one night, then saw it again a few nights later, slightly moved. It flagged this as a potential new object, triggering alerts for astronomers worldwide. This is the power of modern, data-driven astronomy. We are no longer just pointing and shooting. We are systematically mapping the cosmos, creating a dynamic movie of the universe instead of a static picture. The Rubin Observatory generates an enormous amount of data every single night. We're talking about terabytes of information. It takes powerful algorithms and artificial intelligence to sift through this digital avalanche to find the needles in the haystack. The discovery of 3i/Atlas is a testament to this new era of exploration. It wasn't found by a lone astronomer peering through an eyepiece. It was found by a global collaboration of engineers, software developers, and scientists building and operating a cosmic sentinel. Without the Rubin Observatory's legacy survey of space and time, an object like 3i/Atlas might have slipped by unnoticed. Its unique ability to repeatedly scan the sky with such depth and precision is what made this discovery possible. It provides an early warning system for anything new or unusual entering our cosmic backyard. This allows other telescopes with different capabilities to perform follow-up observations, to analyze the object's light, and to determine its composition and trajectory. The Rubin Observatory didn't just find 3i/Atlas, it quarterbacked the entire scientific response, turning a faint whisper from the void into a global scientific symphony. Once 3i/Atlas was confirmed as an interstellar visitor, the biggest question of all emerged: what is it? The debate quickly split into two main camps, creating a fascinating cosmic whodunit. On one side, we have the most likely and scientifically grounded explanation: 3i/Atlas is a natural object. Specifically, it's a gigantic comet, born in the icy outer reaches of another solar system and ejected into interstellar space by a gravitational tug-of-war. This is the simplest explanation, and as we often say in science, the simplest answer is usually the right one. The universe is perfectly capable of making weird and wonderful things all on its own, without any help from little green men. This giant comet theory is supported by some key evidence. As it got closer to our sun, observers noted a faint, fuzzy glow around it, a coma. This is the classic signature of a comet. The sun's heat warms the object, causing ice on its surface to turn directly into gas, a process called sublimation. This gas then escapes, carrying dust with it, creating a temporary atmosphere around the object. The composition of this gas, which can be studied with spectroscopy, can tell us a lot about where it came from. If it's full of water, carbon dioxide, and other familiar ices, it strongly suggests a natural cometary origin. It's a plausible, well-understood phenomenon that we see with comets from our own solar system. However, there's another side to this debate, a more speculative and honestly exciting one. This is the alien megaship idea. Proponents, like Professor Avi Loeb of Harvard University, argue that we shouldn't immediately dismiss the possibility of an artificial origin. They point to some of the object's peculiarities. Its sheer size is one, its trajectory and speed are another. Could it be an interstellar probe from an advanced civilization? Perhaps a giant derelict ship that has been drifting for eons? Or maybe even a light sail propelled by the radiation from its home star? While this sounds like it's straight out of a movie, The argument is that we should at least consider it as a hypothesis to be tested. The scientific method demands that we keep an open mind but require extraordinary evidence for extraordinary claims. The burden of proof lies with those suggesting an artificial origin. So far, the evidence for the alien hypothesis is circumstantial at best. It's based on the object's unusual characteristics, not on any direct signal or observation that screams technology. Most of the scientific community overwhelmingly favors the natural comet explanation. But the debate itself is healthy. It pushes us to scrutinize the data more closely and to question our assumptions. Is it a comet? Almost certainly. But until we know for sure, the cosmic whodunit continues. To really get a grip on the 3I/Atlas mystery, we need to understand the cast of characters that populate our solar system. Let's start with comets. Think of a comet as a dirty snowball. It's a clump of ice, dust, and rock, usually left over from the formation of a solar system. Most comets live in the cold, dark fringes far from the sun, but sometimes a gravitational nudge sends one hurtling towards the inner solar system. As it gets closer to the sun, the heat makes the ice vaporize, creating that beautiful glowing head, the coma, and often a long streaming tail. Comets are icy travelers, cosmic time capsules from the birth of stars. Next up are asteroids. If comets are dirty snowballs, asteroids are big rocky potatoes. They are primarily made of rock and metal and are also leftovers from the formation of our solar system. Most asteroids in our neighborhood live in the asteroid belt, a vast ring of rocky debris located between the orbits of Mars and Jupiter. Unlike comets, they don't have ice on their surfaces, so they don't form tails as they approach the sun. They are barren, airless worlds, ranging in size from small pebbles to giants hundreds of miles across. They are the building blocks of planets that never quite came together. So, what's a meteorite? This one is easy. A meteorite is what you call a piece of a comet or an asteroid after it has survived a fiery journey through Earth's atmosphere and has landed on the ground. While they are still in space, these smaller pieces are called meteoroids. When they burn up in the atmosphere, we see them as meteors or shooting stars. The rare few that make it all the way to the surface become meteorites. They are incredibly valuable to science because we can actually hold them in our hands and study them in a lab. They are tangible pieces of outer space, giving us direct clues about the chemistry of our solar system. Understanding these differences is crucial for the 3I/Atlas debate. When scientists first saw it, they had to figure out which category it fit into. Did it have a tail like a comet? Or was it a bare rock like an asteroid? Or was it something else entirely? The presence of that faint coma was the biggest clue pointing towards a cometary nature. It behaved like a dirty snowball from another star system. This classification helps us frame the right questions and compare it to objects we already know. It provides a baseline, a starting point from which we can identify what makes this particular visitor so very special and strange. 3I/Atlas is not the first interstellar object we've ever met. It's the third. Its predecessors, Oumuamua, discovered in 2017, and 2I/Borisov, discovered in 2019, were groundbreaking discoveries in their own right. They proved that interstellar travel, at least for rocks, was possible. But 3I/Atlas makes them look like small-town tourists next to a globe-trotting giant. Oumuamua was a tiny cigar-shaped mystery, estimated to be only a few hundred meters long. It was so small and moved so fast that we barely got a glimpse of it before it was gone. It tumbled weirdly and accelerated in a way we couldn't fully explain, which is what fueled much of the initial alien probe speculation. Then came 2I/Borisov. This one was much more familiar. It looked and acted just like a comet from our own solar system. It had a clear coma and tail, and its composition seemed pretty standard. Borisov was about 1 kilometer in diameter, larger than Oumuamua, but still a relative lightweight. It was exciting because it was the first object we could definitively call an interstellar comet. It showed us that the comets in other star systems might be very similar to our own. It was a comforting discovery, suggesting that the basic ingredients for planets are common throughout the galaxy. It was a piece of another world that felt strangely like home. And then 3I/Atlas showed up and rewrote the rules. At over 10 kilometers wide, it's not just a little bigger, it's in a completely different class. It is dozens of times larger than Borisov and hundreds of times more massive. An object this big is not easily ejected from its home star system. It takes a significant gravitational event, perhaps involving a giant planet like Jupiter, to fling such a monster into the interstellar void. Its existence suggests that such violent ejections of massive bodies might be more common than our theories previously predicted. It challenges our models of planetary system evolution. This is what makes 3I/Atlas so scientifically important. Oumuamua was the weird one. Borisov was the familiar one. But 3I/Atlas is the epic one. It represents a different kind of interstellar traveler. It's not just a piece of debris. It's a significant planetary building block. Studying it gives us a chance to understand the upper limits of what can be tossed between stars. Each of these three visitors has given us a unique snapshot of the galaxy's population of wandering objects. Together, they are beginning to paint a picture of a universe that is far more interconnected and far more dynamic than we ever imagined. So, this colossal mountain is hurtling through our solar system. What is it actually made of? To answer this, scientists become cosmic detectives using a technique called spectroscopy. They don't just look at the light from 3I/Atlas. They break it down into its constituent colors like a prism creating a rainbow. Different chemical elements and molecules absorb and emit light at very specific wavelengths, creating a unique barcode or fingerprint in the light spectrum. By reading this barcode, astronomers can figure out the chemical composition of the object from hundreds of millions of miles away. It's an incredible feat of remote science. The initial spectral analysis of the faint coma surrounding 3I/Atlas revealed some familiar suspects. We saw the signatures of water ice, which is the primary ingredient of most comets we know. This was a huge point in favor of the natural object theory. Water is the solvent for life as we know it, and finding it in an object from another star system is always exciting. It reinforces the idea that the basic ingredients for life might be widespread throughout the galaxy, delivered to young planets by comets just like this one. But the analysis didn't stop there. The devil, as always, is in the details. What made the composition of 3I/Atlas particularly interesting was the ratio of different elements. While it had water, some studies suggested it might be surprisingly low in certain volatile gases like carbon monoxide compared to comets from our own solar system. This could mean it formed in a region of its home planetary system that was warmer or had a different chemical makeup than where our comets formed. It's a subtle clue, but a powerful one. It's like meeting someone from another country who speaks your language but with a distinct accent. That accent tells you something about where they came from. The chemical accent of 3I/Atlas hints at a different cosmic birthplace. Furthermore, its surface appears to be extremely dark, almost like charcoal. This suggests a surface rich in carbon-based organic compounds, complex molecules that have been baked by eons of exposure to cosmic rays during its long journey. These organic molecules are the very building blocks of life, and finding them on an interstellar object is profoundly significant. It supports the theory of panspermia, the idea that life's ingredients, or perhaps even life itself, could be transported between star systems on objects like comets. 3I/Atlas is not just a rock, it's a delivery truck, potentially carrying the raw materials for biology across the galaxy. The discovery of 3I/Atlas, along with its predecessors, has opened a brand new window into the universe. For centuries, our study of the cosmos was limited to the things within our own solar system and the light we receive from distant stars. We could look, but we couldn't touch. These interstellar objects are different. They are tangible pieces of other star systems, delivered right to our doorstep. They are free samples of galactic real estate. By studying them, we are, for the first time, able to directly analyze the material that makes up planets and comets around other stars. This is a revolutionary leap in our ability to understand the galaxy. These discoveries force us to update our theories about how planetary systems form and evolve. The sheer size of 3I/Atlas suggests that planet formation might be a more violent and chaotic process than we thought, capable of flinging massive bodies out into deep space. It also tells us about the chemical diversity of the galaxy. Are the building blocks of planets everywhere the same as they are here? Or are there different recipes for making worlds? Each interstellar object is a new data point in our quest to answer these fundamental questions. They are clues to the great cosmic story of creation, and we are just beginning to learn how to read them. Ultimately, the study of objects like 3I/Atlas is about more than just rocks and ice. It's about searching for our own origins and our place in the cosmos. It's about the deep human need to explore and to understand. When we look up at the night sky, we are not just seeing distant points of light. We are looking back in time and across vast, unimaginable distances. And now we know that the space between those stars is not empty. It is filled with travelers, wanderers on epic journeys, carrying the secrets of their birthplaces with them. We live in a dynamic, interconnected galaxy, and we are just starting to meet the neighbors, or at least their male. So keep looking up, stay curious. The universe is under no obligation to make sense to us, but it is constantly inviting us to try. Discoveries like 3i/Atlas are a reminder that there are still profound mysteries waiting to be solved, just beyond our reach. Whether it's a giant comet, an alien megaship, or something we can't even imagine yet, the quest to find out is what drives us forward. The final frontier is not just a place, it's a process of discovery. And with every new visitor that streaks across our sky, we take one more step into that grand, cosmic arena. The journey has just begun,